Imagine a lake so beautiful it looks like a paradise on Earth. Crystal clear waters, rolling green hills, and vibrant communities dotting its shores. This is Lake Kivu, nestled in the heart of Africa, on the border between Rwanda and the Democratic Republic of Congo. But beneath this serene surface lies a hidden danger, a silent, invisible threat so immense it has earned the nickname the Killer Lake. Today we're diving deep into the mystery of Lake Kivu, the ticking time bomb that could, under the worst circumstances, endanger millions of lives. So, what makes this stunning lake so potentially dangerous? The secret is dissolved gas, a lot of it. Lake Kivu is one of only 3 known exploding lakes in the world, and it's by far the largest and most dangerous. Its deep waters are saturated with enormous quantities of 2 gases: carbon dioxide, the same stuff we exhale, and methane, the main component of natural gas. We're talking about an estimated 300 cubic kilometers of carbon dioxide and 60 cubic kilometers of methane trapped in the lake's depths. To put that in perspective, that's enough methane to power the entire United States for months. Now, you might be wondering, how did all that gas get there in the first place? Lake Kivu sits in the Albertine Rift, a branch of the East African Rift Valley, which is a hotbed of volcanic activity. Over thousands of years, volcanic vents on the lake floor have been steadily pumping these gases into the deep water. Normally, in a typical lake, water layers mix regularly, allowing gases to escape harmlessly into the atmosphere. But Lake Kivu is different. It's what scientists call a meromictic lake. This means its layers don't mix. The dense, salty, gas-rich water at the bottom stays put, trapped under a cap of lighter, fresher water at the surface. With every passing year, more gas seeps in, increasing the pressure, like shaking a giant geological can of soda. The real danger isn't the gas just sitting there, it's the potential for a sudden, catastrophic release, an event known as a limnic eruption. What could trigger such an event? The primary suspect is volcanic activity. The region is home to active volcanoes, including the infamous Mount Nyiragongo, which erupted as recently as 2021. A major earthquake or a lava flow entering the lake could disrupt the stable water layers. Imagine a massive underwater landslide or hot lava heating the bottom water. This disturbance could be enough to trigger a chain reaction. As the deep water rises, the pressure on it decreases, and the dissolved gases would come rushing out of solution, just like opening that shaken soda can. This would create a massive eruption, an underwater explosion that would force even more deep water to the surface, releasing even more gas. The result? A colossal cloud of carbon dioxide, which is denser than air, would burst from the lake. This invisible, odorless cloud would roll across the water's surface and spill into the surrounding low-lying areas, silently blanketing the landscape. This isn't just a theoretical scenario. It has happened before, albeit on a much smaller scale. In 1986, at Lake Nyos in Cameroon, a limnic eruption released a massive cloud of CO2 that swept through nearby villages. Because carbon dioxide displaces oxygen, it suffocates living things in its path. Over 1,700 people and thousands of livestock perished in their sleep with no warning. Now, imagine a similar event at Lake Kivu. Lake Kivu is 1,000 times larger than Lake Nyos and contains hundreds of times more gas. The population living around its shores is not in the thousands, but in the millions. Over 2 million people in cities like Goma in the DRC and Gisenyi in Rwanda live under this constant invisible threat. An eruption here could be a humanitarian disaster of unprecedented scale. The very thought is terrifying, but here en West, where the story takes a turn from one of potential disaster to one of incredible innovation. The people of Rwanda and the Congo are not just passively waiting for the worst. They are turning this threat into a resource, a source of power and prosperity. Remember all that methane trapped in the water? Well, methane is natural gas. It's an energy source. Engineers have developed a groundbreaking solution. They are carefully and safely extracting the methane from the lake. Picture this, a barge floating on the lake with a long pipe reaching deep into the gas-rich layers. Water is pumped up this pipe. As it rises, the pressure drops, and the methane separates from the water. This extracted gas is then cleaned and piped to an onshore power plant, where it used to generate electricity. The degassed water, now denser, is carefully returned to the depths of the lake, ensuring the delicate balance of the water layers isn't disturbed. This process not only generates much-needed electricity for the region, reducing reliance on burning wood and expensive imported fuels, but it also serves another critical purpose. Every cubic meter of methane removed makes the lake safer. It reduces the overall gas concentration, effectively disarming the ticking time bomb, 1 megawatt at a time. One of the flagship projects leading this charge is KivuWatt, a massive facility that looks like something out of a science fiction movie floating majestically on the lake. It's a testament to human ingenuity in the face of a daunting natural challenge. This project is turning a deadly threat into a symbol of hope and a source of sustainable energy. It's creating jobs, powering homes and businesses, and most importantly, it's slowly but surely reducing the risk of a catastrophic eruption. Local communities, once living in the shadow of the lake's power, are now benefiting from it. It's a win-win situation. However, the challenge is immense. The amount of gas that needs to be removed is staggering, and the process is slow and expensive. While the current extraction efforts are a fantastic start, scientists estimate that at the current rate, it will take many decades, perhaps even centuries, to fully mitigate the risk. The gas continues to seep into the lake from below, so it's a constant race against time. The key is to extract the gas faster than it's being replenished by the volcanic vents below. Continued investment and the development of even more efficient extraction technologies are crucial. The international community and scientific experts are watching closely, supporting these efforts and monitoring the lake's stability. They use sophisticated sensors to track gas levels, water temperature, and seismic activity, creating an early warning system in case the unthinkable begins to happen. So, Lake Kivu remains a place of stunning paradoxes. It's a source of life and livelihood, yet it holds the potential for mass destruction. It's a natural wonder that inspires awe, and a scientific puzzle that demands our respect and caution. The story of Lake Kivu is not just about a geological anomaly, it's a powerful reminder of the delicate balance between humanity and the immense power of nature. But more than that, it's a story of hope. It shows how science, engineering, and collaboration can be used to confront even the most terrifying natural threats, transforming danger into opportunity and securing a safer future for millions. The fate of the 2 million people living around Lake Kivu rests on the success of these incredible projects. It's a race against time, geology, and chemistry, fought with pipes, pumps, and human ingenuity. The killer lake is slowly being tamed. Thank you so much for joining us on this deep dive into the mysteries of Lake Kivu. If you found this story as fascinating as we did, please hit that like button and subscribe to our channel for more content about our amazing and sometimes dangerous world. Don't forget to ring the notification bell so you never miss an update. We'll see you in the next video.